Today we're going to learn about isotopes. Now, if you're viewing this for a class, then you should realize that this is now week 9, lesson 1. Okay, and we're going to learn about isotopes, specifically isotope notation. Alright, so far we learned how to figure out protons, neutrons, and electrons, right? We looked at the periodic table square. We saw that, okay, yes indeedy, this was the atomic number right here. Alright, that was easy to spot. It's always at the top. Alright, then we looked at it again and we said, okay, well, this is the average atomic mass, and we used it to find the mass number. Well, things are now different. And I told you while we were learning this that it was okay for us to round this. And that's what we did. We would round this to the nearest whole number to find the mass number. But we're now learning about isotopes. And this is not the mass number. This is the average atomic mass. Okay, now this is a big deal because no longer are we rounding this. No longer will we use that to figure out protons and neutrons. The average atomic mass is not the mass number. Okay. Well, how do we figure out the mass of a single atom? Or why would they even be different? And that's what we're going to learn about. We're about isotopes. You see, because isotopes are atoms of the same element, all right? So it's the same element that have a different amount of neutrons. All right, so we learned how for a stable element, protons and electrons have to be the same number. And we used math to figure out the number of neutrons. We used the 8-man strategy to figure out that the mass number minus the number of protons gave us the number of neutrons. Well, now we're finding out that we could have a different amount of neutrons, but yet be the same element. Well, I mean, how is that possible? How could we even figure it out? How could we tell them apart? Simply the mass number. Okay, so elements could have different masses because of different amounts of neutrons. So let's think about it. Okay, so think of a Milky Way bar. All right, I have sitting in front of me a king-size Milky Way bar. I have the little snack size, and then I have the bite-sized ones. All right, and if we were in school during Halloween, which, sadly we're not, we're on virtual here, I could bring in this candy and show you. Okay, well, sure, they're all Milky Way bars, but they all have different masses. All right, and that's what isotopes are. It's still that element. All right, it's the same element, but they have different masses. They weigh different amounts. And it comes from a different amount of neutrons. That is the key. And we know that neutrons were neutral, so that didn't play a role in the overall electronic stability of the atom. All right, positive and negative is not affected by the amount of neutrons because neutrons are neutral. All right, so let's take a look at a real example of this. Now, this is a picture of 3 hydrogen. All right, so it's all hydrogen, but we have 3 of them. All right, we have hydrogen that has 1 proton, 0 neutrons. All right, we have another one that is 1 proton and 1 neutron. And then lastly, we have 1 proton and 2 neutrons. Okay, I want us to notice one commonality that all 3 have. Okay? They still just have 1 P and E. All right, so all 3 just have 1 P and E. We can't change this for a stable atom, all right? Because we know that the atomic number has to equal the proton number. It has to equal the electron number. We learned that last week, all right? you can't change the number of protons and still have the same element. But obviously we have changed the amount of neutrons and still kept the same element. All three are hydrogen. All right, the only difference is the amount of neutrons. And if you look at it, we now have a different mass. The first one is 1 proton. All right, so it's a mass of 1. This has a mass of 1. All right, because only protons and neutrons have mass in the element. All right, the second one has 1 proton, 1 neutron, so this now has a mass of 2. And the last one has 1 proton and 2 neutrons, so it has a mass of 3. So what we said is backed up by this. The amount of neutrons change, therefore the mass changes. All right, our role for today is figuring out how to write or list these isotopes. Like, how could we figure out the difference between these isotopes? Because some isotopes have different functions for that element, and we'll learn about that later on. Like, why do we use carbon-14 for carbon dating, but not carbon-12? And we'll look at that later on. All right, now the way we write these isotopes is called isotope notation. That's what we're going to call it. All right, and it's a special way of writing isotopes so we know which one we're talking about. All right, so let's go ahead and look at this. All right, the element symbol is right here. We write it all big like, and when we write it on paper, it's going to look like a normal size font. All right, but that's the element symbol. Okay. The next step is to write down the atomic number. This is in subscript. All right, and the atomic number is the thing that we see on the periodic table. We called it the unique identifier for that element. And then lastly, we now have a superscript, and that is the mass number. All right, the mass number. That would be the number of protons plus the neutrons. All right, so let's take a look at a little mini example of this. Say I had carbon, and we've looked at carbon before, and we had carbon that had, let's say, 6 protons, of course, and 8 neutrons. All right, how will we write it in this form? Well, the first step is we write the symbol C. All right, the next step is the atomic number, which is also the number of protons. So all we have to do is write 6 right there. See how that just goes and fits right down there. All right, and then we got to go with the top part. Now, the top part is the mass number. All right, the mass number. What are we going to write there? Well, it's the number of protons plus the number of neutrons. So 6 plus 8 is 14. So this is the isotope notation for the specific isotope of carbon. All right, now there's a different way of writing this, and some of you all might like it better. All right, and we're going to go over it right now. This is like the official way, the best way. It gives you the most information. It tells you the mass number up top and then the atomic number below. All right, this gives us the best information, but scientists are lazy and they wanted a new way to do it, especially while in a typewriter on computer, because superscript and subscript are pretty difficult to do. And so this is the second. Paying attention to this, the atomic number is at the bottom. All right, if we were paying attention, we know that the mass number is that top thing. So screenshot this and keep it in your notes. Way of writing it. All right, and this one's easier to write. All we got to do is write the name of the element and then the mass number. So we have the element name. You just write it out completely. Okay, that's the element name. And then X is the mass number. All right, so that's the mass number right there. Okay, so let's look at an example of this. So we talked about how we had our carbon, right? And our carbon had 6 protons and 8 neutrons. All right. So we'd write out carbon. we put that little dash, and then we would write the mass number. Well, the mass number is the 6 protons plus 8 neutrons, which make 14, so we just write carbon 14. All right, and this is our answer right there. You've probably seen this example before when talking about medical stuff or in a science notebook. All right, this is the most common way that people type it just because they don't like putting the subscript and superscript. All right, now for our work that you're going to do for homework, all right, and before the quiz, is you're going to have to figure out the atomic number, mass number, number of protons, number of neutrons, number of electrons from these isotope notations. All right, and so we're going to practice a couple examples of these so you could get it down. All right, but we still got to remember isotopes are elements, all right, that have different masses due to the different amount of neutrons. All right, they're atoms of the same element that have different masses. Just keep repeating it to yourself if you have to. So since let's go back, all right, this thing at the end after that dash, that is the mass number. So or take a picture of this, then that would be very helpful. All right, so we're going to work on some isotope examples. Let's go ahead and we need to go full examples. Okay, so this is kind of like what your homework and the practice and the quizzes are going to look like. I'm going to give you the isotope, and you got to figure out the things that we learned how to do last week. So let's go ahead and work this out. All right, looking at isotope notation, and I give you the little periodic table square as help right now. And while you're doing your homework and stuff, make sure you pull up that periodic table quiz I gave you on Google Classroom so you could look up these answers. It's really difficult if you don't have the periodic table in front of you. All right, so the atomic number, which we go, there we go, that's the atomic number. All right, so that's 46. And we know that A is equal to P equals to E, right? We learned part of 8-band. So if I know the atomic number, I also know the number of protons and the number of electrons. Same number. All right, now we got to look and figure out what the mass number is. Look at it. Okay, well, this right here is my mass number. That's my mass number. So I could go ahead and write 110 right there. Okay, well, how do I figure out my number in neutrons for this specific isotope? I take the mass number minus the atomic number. All right, so the mass number minus the atomic number is 110 minus 46, which is 64. Yeah, if you had to use a calculator, that's fine. But no, I was able to find out all this information by looking at my isotope notation. All right, and it also helps, of course, when I have my handy-dandy periodic table square. Now let's go ahead and work on. Well, we went ahead and you could reference then and see if we could do the same thing. All right, we know that the bottom number is my atomic number, and we know that A is equal to P is equal to E. So if I know this is 26. I know that this is 26. This is 26. All right, so all three are the same number in a stable isotope, a stable atom, which they are for our examples. All right, we know that this top one is our mass number, so we can just go ahead and write that down, 60. Okay, now the next step is figuring out our number of neutrons. All right, so that, of course, is M minus A. So 60 minus 26 is 34. That's how we found that one out. All right, so those are 2 examples for the isotope notation. Now let's learn how to do it the shorthand way. All right, so here we go. Note, I have less information now on this, so I gotta really focus on what's given to me. Okay, so we know this is sodium, and we could look this up on the periodic table right here. All right, we know we could look it up on the periodic table, and you could always use your periodic table. You never have to ask, hey, can I use my periodic table on this quiz, this test, this worksheet, this project? You always have permission to use periodic table. I never expect you to memorize that. So we know, looking at a periodic table, that the atomic number is at the top. And by the way, this square is the exact same one on the periodic table I sent you. All right, so that's my atomic number, which A equals P equals E, all the same number. So we just write them in right here. Okay, now we got to figure out the mass number. But look, make a note, that's my mass number right there. So I could put this number over there, 25. Okay, so far so good. And now we got to figure out number of neutrons, which by now you've memorized that it's the mass number minus the atomic number. So if I take 25 minus 11, I get 14. All right, that was a little bit easier math. Okay, that was easy. Okay, let's go ahead and work another homework. All right, I got potassium 40. First things first, so let's look up our potassium on the periodic table. All right, we did. That's our atomic number right there. So it's 19. And since A is equal to P is equal to E, we could say that it's 19 on all of them. Okay. Next step is looking up the mass number or figuring out what that is. And we know from this isotope notation that the second thing is our mass number. So I could just write 40 right there. And the man part of ape man goes M minus A is equal to N. So the mass number minus the atomic number gives me the number of neutrons, which is what I'm looking for. So 40 minus 19 is 21. All right, so once again, we were able to find all the information out. All right, so far so good, huh? And you could always stop this video and go back to the beginning where I describe it or look at the examples. Okay, it's all for you to make sure that you could do the. All right, but let's do a little challenge. Let's see if we could think about this in reverse. All right, can we put an isotope into isotopic notation from the following information? I give you the number of P, E, and N. Can we put it in the very formal isotope notation? Oh, and that's the one that looks like this, by the way, and I'll put it up in the top. The mass number, the atomic number, and then the symbol of that element. All right, yeah, we could figure this out. We could do this. First of all, we know that the number of protons is the atomic number. So we got this number down at the bottom. We know it's 20. Okay. Well, is that enough information to go by to figure out what element we're talking about? All right, yeah, we could look this up. All we have to do is look this up on the periodic table. All right, and then it will tell us what element is. And then the element that has the atomic number of 20 is calcium. So we write that right there. Okay, now we got to figure out what the mass number is. Well, the mass number, that's not that bad to figure out. Mass number is the number of protons plus the number of neutrons. We see that that is 20 plus 22. So my mass number is what? 42. So we just go ahead and write that down there. So we could even work backwards if we wanted to. And don't worry, you will soon need to work backwards and be able to put them in isotope notation. But as long as you keep track of what each position stands for, and if you go back and screenshot the isotope notation help sheet, but we could do that. We could use this information and go backwards. All right, now, and this is specifically if you are missing class and viewing this video. All right, so if you're missing class and you're viewing this video, this is your exit slip to get some participation points for the day that you missed out on. All right, I want you to look at this problem and I want you to figure out this information. Now, pay attention. You need to send me this either on Google Classroom. Okay, it will be underneath the participation assignment where I sent you the link for this video, or you can send it to me on Remind Text. And what you're going to do is you're going to send me these numbers that will go right here. You're just going to send them to me, all right? And that will be your exit slip. Well, if you have any questions, let me know. You could contact me or your teacher. You can go back and view this video, but keep working.